right, great. We have a full room today. Thank you. Good afternoon, San Francisco. And for the first time in the past 4 years, I'm here in the summer. I'm not freezing my butt off. I'm from Florida, and I know you're laughing, but we get to pick who is the next American president. So think about that. My name is Christina, and I am the data engineering lead at Abridge AI. Abridge uses generative large language models technologies to translate patient-clinician conversation into medical notes and integrates deeply into the EHR system. There is, as we speak, an exciting senior data analyst opening on my team, so feel free to check it out on our career page. What we will be discussing today, though, is industry and technology agnostic. So I want to show you a way to think in a data-informed way and make use case-specific adjustments to your tech stack. So here's our agenda today. We're gonna start with a little bit of motivation, and I will walk you through an iterative journey for several different flavors of change data capture, starting with SaaS applications into relational databases and event streams. I will present you some alternatives, and so you can evaluate yourself and see what works for your use cases, and then we will conclude with some closing remarks. All right, I want to take a quick poll here. So how many of you here in the audience are just starting your data or AI journey? Like maybe first job on the field. Okay, so how about 5 years of experience? Okay, 10 years of experience? Wow, okay, very advanced audience. And let's start with a little bit of a history lesson. So about 2014, right, that was 10 years ago, right? That was when I first entered the world of big data. And there used to be a data warehouse versus data lakehouse debate. And I think Google really wanted me to take note of when these two lines are converging. And just in case, and anyone who's less familiar with this, I put this from Google Trends, and you can reproduce this yourself. So now we're at year 2024. So I think the debate is already won. We know what we want, what is the best possible of both worlds. So everybody wants a data lake. But then how do we get here? And everybody has data everywhere. That comes in all forms, shapes, and structures. And how do we build a single source of truth? So I love this confused data team meme, one of my favorites, and I keep recycling it. So I want to show you a little bit of our journey with ingesting data from SaaS applications. So at the beginning, we introduced that maybe the core to building the centralized data lake is an incremental problem. So your initial load is easy, but how do you do it incrementally? How do you keep your target in sync with your source? And how do you do it efficiently? Maybe some of you are already familiar with this view. We used to use like an older Databricks product called Overwatch, but I think the linear system tables is so good these days, you may not have to reproduce it yourselves. So like all of these specifics is less important to you, but what I want to highlight here are the trends. So we analyze our usage, and we see the resource spikes. And what we wanted to know is why. So I'm not going to tell you what we did specifically. I think it doesn't matter. What matters is the impact and how we learned and what we learned. So as you can see here, we try to do work in less latency, right? So we want to finish this pipeline in 2 hours instead of 12. Moreover, we have a budget. So we want to decrease the latency, increase efficiency while still sticking to the same budget. We're able to achieve it. We're able to do the work 6 times faster, but with the budget originally only 1/4 of the worst possible scenario. And how did we get there? So a few lessons that I want to show you, and it is my job here. Things we have suffered, I'm hoping that you could suffer a little less. And at the very least, I'll give you some comedy. Okay, so the first we found is default. So like probably many of you here were using SaaS connectors for our EL use cases. It doesn't matter, it could be a vendor, it could be an open source technology. But I want to check on the source code from the Airbag community. I want to understand how exactly the Redshift connector was written. So there in the documentation, written in the Python comments, that says by default, the Redshift connector uses an insert over write. So, okay, so I'm thinking to myself, Redshift is a columnar storage. I want to do row-level inserts into a columnar storage. Okay, so no wonder my connector is a little slow. Further down in the documentation, it is stated that it's possible to be more efficient, but doing so often requires more infrastructure setup. And what does that mean for a Redshift destination? Is you're better off setting up an S3 intermediary and use a copy command. Second one, so we're using Databricks classic SQL at that point. So we could look into the query logs, and I saw the commands being run was merged into X using Y. Okay, so that's by 1,000 cuts. You have a lot of little merge statements, and went to check the EC2 console that classic SQL spun up. So I'm realizing most of the time this cluster is underutilized. So why does this scale up but not down? So this auto-scaling policy in our AWS environment is a little problematic. So we ended up working with our Databricks SQL team to change this behavior. And by the way, this was pre-serverless support for EL connectors. So what I wanted you to do is you can observe your warehouse behavior. Look at what's really happening under the hood once you're doing the ingestion, and maybe compare it to the serverless offerings. So the evaluation is really important. What is your success criteria, right? So define the success criteria in your mind ahead of time, and then you can do your own benchmarking. So you don't have to trust what I said or whatever the serverless expert or your cloud vendor expert. So, but do this test yourself. The last one is please invest in observability. So draw that graph, have the before and after. So use system tables. If you're on Azure, great, many things came integrated. If you're on AWS, set up that billing and log delivery. So the information will pay dividends in a long time. If you're on Google Cloud and you want to do observability, I wish you the best of luck. All right, so let's get into the bread and butter today. Changing the capture, CDC, right? So that's solution to the incremental ingestion problem. So I'll do it a little bit of a time incrementally. So how? So I'm going to show you a few of my iterations. Let's rewind a little bit ahead of time. So in the beginning, so I was moving mountains. Okay, so joined a startup as a founding engineer. Databricks has just released Autoloader, where Spark experts were like, oh, here's a great system that can automatically discover new files and ingest it into Delta format. So I know the second half of the puzzle. I just need to find a service that is able to capture change and move it into S3, then problem solved. I can do this. So my research at that time led me to Amazon's database migration service. You choose your source, you choose your target, and DMS has two modes, snapshot and incremental load. So that sounds great, right? So at the beginning, you take a snapshot of your current database, and then incrementally, it writes change files into S3 or Redshift or whatever, your target database. That all sounds great, and it's a managed service, and I'm a data engineer. I don't have to do any of the DevOps stuff. Okay, so I was here in 2022 presenting this architecture. I thought I had it all. And actually, 2 years later, and I came to really regret it. What I'm not trying to tell you is do not use Amazon's DMS service. That is not what I mean. But what I do want to tell you is why it did not work for our use case. So let's take a look. Pitfalls. So first of all, it was a bit of a deployment nightmare, so I tried it. It worked for one of our services. Write the Terraform, go to the DevOps team, hey, please help me scale this. But we need to deploy this to 3 environments and 20 microservices. So Terraform, right, whatever, CloudFormation, you want an infrastructure as code tool. But what we found was that there were some limitations with the Terraform provider. And while maybe 95% of the configuration could be automated, but then that annoying 5% requires human intervention. So like you still have to manually modify stuff for 20 services. That was pretty annoying, and I was much hated by the DevOps team for implementing this. Okay, so next. We found in production a lot of limitations with DMS service with our source and target. And it was actually pretty clearly documented in AWS itself, but a little bit of prompt engineering work for you to be able to find that specific answer. So you have to tell Google, what is your source and what is your destination? And when you go read AWS documentation, so limitations of X regarding A and B. So what I found was that there was like about 40 different kinds of transactions not supported by using Postgres as a source. And thankfully, our target was S3, big believer in open source, open format there. But if you're using like a data warehouse target, you have more limitations on the data sides that can be transported. But anyway, so I am the lead of the data team. I don't control what our applications are doing. I can't tell an app developer, hey, don't rename tables, don't drop column, do not create a temp table and swap them. So that is beyond my knowledge and or control. And I think that is beyond too much of an ask for many data teams as we're here. But okay, so I was also much hated by the app teams because I had to tell them, you cannot do this. Last, but not least, so since this is a managed service, we don't always know when it got stuck and why it was failing the way it failed. So I had AWS support on my speed dial all the time. It's always a call for an engineer. Hey, dig up some logs for me. Why? And the solution, you click that scare red button that says restart the service from the beginning. Retake the snapshot, redo the incremental ingestion. And at that point, I was wondering, just why the hell am I using a database migration service at all? I might as well do PG dump, PG restore all day long, every day. Okay, I didn't have to go through all this headache. And I started hating myself. Okay. So that didn't go exactly well. Again, do we have any Amazon employees here? Okay, sorry, just checking. This is San Francisco. I don't want to get stabbed on the street. But okay, good to know. Again, I'm not attacking Amazon managed service. I'm just illustrating what to watch out for and why it didn't work for our own use cases. So do you have one of these edge cases? Well, check the documentation before you commit. All right, so that didn't work exactly well. Iteration number 2. So I'm going to swap that with a de facto open source standard, right? And then, fast forward another year, we have Delta Live tables. So that makes ingesting change data even easier. So the 25 line of code that I used to write in Scala is 5 lines with DLT. Apply changes. I know what to do from here. And I have a robust, feature-rich, real-time system called Debezium. I have like-minded colleagues that are determined to help me make it to get there. This is the best day of my life. I can solve it. All right. So I am not going to stand here and talk to you about Debezium architecture. Well, it's probably going to take a whole book to explain this. The documentation is pretty rich. Only thing I want to highlight is all this green box here. This stuff is actually pretty complicated. Debezium uses something called write-ahead logs. So it's kind of like the database keeping track of its own changes and keep it in something called a replication slot that sits on disk to manage. And then you have a Kafka Connect component with Kafka, Zookeeper, typically runs in a container. And then finally, the change events are emitted into Kafka topics and that you can consume. So I might have gotten the .left table part figured out, but this whole box, none of this is trivial. So first lesson I've learned is this stuff is complicated, and you require a lot of really strong DevOps support to be able to succeed. So just managing and tuning Kafka itself is non-trivial. But you add Zookeeper and the database's own replication slot. That's lots of moving parts working together. So any of them fails, and that system that can potentially become a point of failure. Okay, so we're a startup, and I've got like 3 data engineers, and the SRE team was also like 4 people that need to support the entire company. We feel like we really didn't have a Kafka or Debezium expert, so to speak. I'm not trying to say that any of you won't be successful with it. Please take up my challenge. Let me know how it goes. The only thing I want to caution is this is kind of complicated. You deploy it, it runs, but then how do you maintain it on an ongoing basis? Keep that in mind, okay? So developer satisfaction is also pretty important. Once again, I was hated by the DevOps team because anything Debezium related is a P0. Data is our product, right? So they didn't like me very much. Number 2, so I will tell you that why I was hated by the app teams again. So transactions. So I mentioned that Debezium uses replication slot, right? So although the idea of CDC is you want as little impact on the source system as possible, but it does use a little bit of database's own resources. So the replication slot, remember, sits on the source database. So what I found that also in production is that when the application issued transactions, so sometimes then it doesn't care anymore. Okay, my job is done. The query is not even known to the application anymore in certain edge cases. So my work is done, and then that's how you want to capture the change. That's your data team's problem, right? So from an application perspective, I'm all good to go, but the long-running transactions often blocks the replication. And then, so once the write-ahead logs start building up, so eventually the replication slot gets full, and then in turn, it starts affecting the application. Oh, can't write to the database anymore. So we just enter like a weird cycle, a weird vicious cycle when the application and changes are captured affects each other. So, so the extreme things, what I will have to do is, okay, so we got kind of good at it. We're looking at the replication lag. We're looking at the transaction logs. We're like, okay, here is a long-running query. Whose is this? Can I kill it? And like everyone's DMing everyone on Slack. And nobody's happy, and because the application would have to retry the query later on. That's client data we have to produce, right? Again, I was hated by the app teams again. Okay, so the last one is one thing that Debezium does capture is every change, right? So every insert, update, or delete. And some of this, the downfall is really, it goes back to our own data modeling. Unfortunately, because of the flexibility we need for our services, we use something called JSONB in the source Postgres database. So it's like Postgres version of variant or unstructured data when the application doesn't want to figure out or doesn't really have a way to enforce a schema on the column, so use JSONB. But here, I'm gonna go back to some database fundamentals. So what do you think a columnar storage is good for? So that's aggregation. So group bys, min-max. What do you think a row level database is good for? So with your indexes and keys, that's updates, right? So if you want to do key level lookup, select something from table where ID is 1, and then, or if you need to make the update on ID is 1 for certain fields, so that's when row storage really shines. And then when you have something like a document storage and a JSONB column, that makes the write pretty easy, but the lookup or specifically updates pretty challenging. So if you want to just update a certain attribute in your document, so we ended up having to rewrite the entire document. So that was the reason that there were so many changes and blocked transactions as seen by Debezium. We really didn't want to capture all of these updates to the fields. And we really didn't want to capture every one of them. It turns out our customers are quite happy with like a 1 hour delay. So we didn't have to do like 1,000 updates in an hour. And we just don't need that level of granularity. And if you're writing DLT or any manner of like changes, you know you only need the final state of that record at whatever frequency that makes sense to you. Okay, all of that. It is not stressful at all. So I want to reimagine this a little bit. I think to myself, so how do I have a different kind of CDC, right? So how do I do it differently? This was a running joke on my team, by the way. And I don't know about you, but I like craft beer. I want to be drinking cans. This is where I flash out my Florida sunglasses and sit back on the beach and giving my team thumbs up on the Slack, right? So I want to be drinking cans. And how? And I've come to realize that change data capture, it doesn't necessarily mean event or log-based change data capture. But if you read literature today, quite often those two are used synonymously. Many reasons for this, state of the art, latest and greatest, vendors, providers, people who help you simplify this. You can simplify this yourself. So I will say there are actually much simpler ways to think about the incremental problem. So the first one is called query-based change data capture. It just uses simple SQL queries and a timestamp. So basically, all you need to do is select something from table where last updated timestamp is greater than last ingestion time. And if your table has a primary key, you want to make a composite primary key, you can go back a little further, let's say a few seconds or minutes, and to make sure that you don't miss any data. And then from there, once you get the newly updated record, it's a simple merge statement. Merge into target using source. So it definitely, you don't need to involve DevOps or application teams for this. So any data engineering team, even some highly skilled data analysts, you'll be able to do that using something like a dbt incremental. Caveats here is that, okay, you have to have a timestamp. Your table needs some kind of created or updated that. And two is please do this against a read replica. Just please never quote me that I taught you something that brings down the production database. So maybe do not run this against a master node. Use a read replica. So, okay, pretty straightforward. There is another alternative. It uses pushing. So those are database triggers. So you can execute statements that you like in response to an insert, update, and delete statement. So bear in mind, also, the caveat here is that triggers use databases' own resources, so it can be pretty intensive. So make sure that you monitor your source database correctly. So maybe you do need your app team's approvals here. A little more involved, but it can work fairly easily. No additional system. You can do everything entirely here within your own database. All right, cool. So where do we go from here? Probably it will not get me invited to conference anymore. I don't know. Maybe next year I will be canceled. But this is what I ended up realizing, okay, so remember I was moving mountains, right? But if the mountains cannot come to Muhammad, then Muhammad must go to the mountain. What does that mean in practice? I'll show you what we did. And it is so simple that you are probably going to laugh. Like, why am I here at all? Okay, so plain old Spark JDBC connector. So I like this because I have control over things like fetch size. I don't want to overburden the source database, but I also want to parallel process. The Spark documentation here is a little sparse, so it took a little bit of experimenting for us to get the syntax exactly correct. You can use the DB table option when you're reading from the source, but make sure that together with the partition column, you also have something at the source to partition on. So in our case, is a timestamp, but you could also use like region or anything that makes sense to you. And how did we get the number partition number 16? Again, if we go back to the fundamentals, I have a 4-core cluster. In this case, sorry, I have a four machine cluster, each with 4 cores each. 4 times 4, 16. So I want my number of workers to be equal to the amount of compute cores I have. Although, I don't know, think about our announcement earlier. Maybe when serverless workloads are really here, I can take this complexity away from me, so I don't have to worry about clusters matching and all of this provisioning anymore. But anyhow, try this and try the serverless and do your own testing and see what works best for you. All right, and for those who are on Unity Catalog, you could equally set up a foreign catalog. And it's even simpler. If you want to read a Postgres table, it is just Spark table. Keep in mind that Query Federation, at least at the time of writing, it uses a default parallelism of 1. So it is not meant for you to real-time live read terabytes of data set. But if you want to have a little more control of that behavior, just use the plain old Spark connector. All right. Okay, so I want to, since it looks like we have a little bit of time, I want to take a minute and really think about what we got us today. When I look back 2014, it is that I fell in love with a system called Apache Spark that where you write your code, and that is by nature parallel. So you don't have to think about all these partition and distributed computing work, and the code just automatically does that for you. So let me see. Let me show you this real quick. Do I have Wi-Fi? Okay. So this is Dragonfly telescope. It uses commercially viable product. So all of these lenses. Oh, I realize you don't see my screen. Okay. It's called Dragonfly telescope. Anyways, if you can imagine Dragonfly, their eyes and how it works, and you can take like a photographer's lenses, like all these huge Canon lenses, you put them side by side, 64, 128, 200, and so a commercially viable product. So grouped together, working together, you can see the faintest dark objects in the sky. It's super powerful and definitely a bit of a gimmick in astronomy. But okay, maybe this is the lesson that the founders at Apache Spark tries to teach us. I think it's super cool. So I wanted to close out by a little bit of technology that I want you to try and see how it works for you. All right, if you haven't tried liquid clustering, please do. As we know, Spark is a very powerful parallel processing system. But maybe one of its complexities, you have to get your partitions right. You don't want your files to be too small, or it cannot be too big. And you don't want them to be unevenly distributed, because if you think about this four machines, 4 cores example, I hope it becomes a little more explicit. So you don't want one person to do all the work, right? And the other one just sits around. So in traditional partitioning, you have to do this yourself, and if you're not careful, you got this. So it's just blocked by the one with the greatest latency. But with liquid clustering, and that's really the namesake, liquid, that it kind of does it for you like a managed enterprise data warehouse, and you have more or less evenly distributed, we don't call them partitions anymore, clusters. From my test, we're able to get a 4 or 5x improvement in the write performance without taking any performance in the hit in terms of the read. So our whole idea of partitioning by customer was that to enable faster lookups, but reshuffling the data while during the write, it actually consumed a lot of time. With Liquid, we don't have to make such a trade-offs anymore, and we don't have to also guess, what is a sensible partition? And this cluster doesn't suffer from some of the limitations of a traditional data warehouse clustering. And this is, by the way, something that I read when setting up a cluster table on BigQuery. You can cluster however you like. It's pretty intelligent, and but the querying order, it will matter. So for example, if you cluster down, let's say, customer name and region, actually customer name, bad example. Let's say customer vertical, right? So your enterprise standard, and customer vertical and region, right? So it only works if your users are also querying group by customer region, customer vertical first, and then region. If your users reverse the group by order, that clustering actually is not gonna work for you. Just check it out, it's in GCP documentation. And don't use ChatGPT, and ChatGPT is very, very bad at that. GPT is great in looking up common popular languages, transformations, but it's really not great at combing through data vendors' documentation. Or maybe I just haven't paid enough money to get the latest version. I don't know, but look this up yourself. But my recommendation would be for you to try this out and do your own testing. Okay, closing. This is totally not a pitch for the data teams here. So why am I not talking about AI? I do have AI in my company title, and if I don't, I might as well be scrubbing the porta potties on Mission Street. Okay, thanks, San Francisco. But what I want to say is that every company wants AI. Every executives or strategic product managers, they want it. But I want to say that the model you're using, it's probably originally developed by somebody else, whether it's an open source, OpenAI, or it's the best, but the data is yours. So it's for the best performance on any AI use cases, you probably need to fine tune it using your own data that fits for your own specific purpose and use cases. So my recommendation here to you is, please, evaluation is everything. So don't trust everybody else's benchmark, because that's fine-tuned for that specific use case. What is your success criteria? So how do you define good? So how do you measure it? Keep that in mind. You make everything as simple as possible, but not simpler. Your development team, your developers, your DevOps, your application teams, they will thank you. And hopefully, at the end of the day, they won't hate you as much as they used to of me. Okay. All right, that's all what I have for today. So do your own testing. Let me know how it shakes out. Thank you.